So now that we've discussed how we can interpret definite integrals as area and how they're similar but also a little bit different, since area is never negative but definite integrals can be negative if the area is below the x-axis, we can discuss how discontinuities affect definite integrals. Because we did talk about how if a function is continuous, it must be integrable. But the converse is not necessarily true. Now's the time that I want to discuss when will the converse not be true. In other words, for what discontinuities is a function not integrable? So we're going to look at the integral from -1 to 2 of the absolute value of x over x with respect to x. And graphically, the absolute value of x over x looks like this. When x is greater than 0, I don't need the absolute value signs, and I would just have x over x, which is 1. When x is less than 0, I'd really be doing the -1 times x instead of absolute value of x divided by x, which is -1. And at 0, I'm not allowed to plug that in, so it's open dots at both. So I have a discontinuity at 0. Well, I can still think of this in terms of area, where from -1 to 0, my area would be 1, but because I want to think in terms of the integral would be -1 because that's below the x-axis. And from 0 to 2, my area would be 2. Because that's above the x-axis, the integral would also be 2. So when I do the integral, I'd have the -1 plus 2, which is 1. So our discontinuity did not actually have an effect there. We were still able to find the integral by using areas to do that. If we look instead at the integral from 0 to 2 of 1 over x, I'll just to clean up the picture a little bit here. This will not exist, and the issue has to do with the fact that we do have a vertical asymptote at 0. If we think in terms of RAM, if I were to do R RAM, there would be one rectangle, there would be another, there would be another, there would be another, there would be another, there would be another. But because with RAM, ideally we're going to infinitely thin rectangles so we could get an infinite number of them, how tall would my last rectangle be? Well, because the height is going off to infinity, I can't actually find the height of that rectangle. So I can't find its area, and I can't add those areas up, so the integral would not exist then. If I had said my limits of integration were from 1 to 2, where the vertical asymptote isn't between them, then I would still be able to find it because it would be continuous from 1 to 2. But because of the vertical asymptote, I can't find that integral. And it's kind of the rule of thumb here. The infinite discontinuities, in other words, the vertical asymptotes, are not integrable. But every other discontinuity, we can go ahead and integrate over. It's not going to hurt anything.